Good morning, students, and we are continuing. See now, whatever the formulas we got in the previously, okay, on the formulas only we are going to go through some numerical like this, okay, and some conceptual question like that. And okay, see what the concept says is means how in examination the question will be asked is. See, you have learnt I is equal Q by T, and the formula for this current is, that is I is equal Q by T, and the unit for current is ampere, you have learnt. But in exam, in what way the question will be asked, and what you are going to, in what way you are supposed to write the answer. So to say that, what you call after the explanation of the concept, I am saying about the question and answer. Then we will go to the next topic and all. See, the question will be asked in the exam like this: what is the SI unit of current? Okay, means current means total name of current is electric current, like that, define it. So I said you, when you are writing the unit which is named in honor of the scientist, actually the name, okay, ampere is actually, it is the name of the scientist. So the unit for current is given in the name of scientist. So when you are writing the unit named in honor of scientist, you have to write capital, okay, if you write only in symbol form. If you want to write total name, then you have to start with lowercase alphabet. So that's what I said here. The SI unit of current is ampere, I wrote, okay, otherwise capital letter, okay, in bracket, done. Now definition means what they said, define it. They are not saying to define current, they are asking to define ampere, means it means that 1 ampere. Then you should not write current definition, you have to write SI unit definition, means so means you have to write definition of 1 ampere. See, so that is the reason, to get conceptual clarity, what I did, I wrote the formula I is equal Q by T, 1 coulomb per 1 second. So thereby it will give you how much, if I is equal Q by T, you will get 1 ampere, right? So to get the conceptual clarity, this mathematical form we have to write in definition form. How? See, I showed you the circuit diagram in the what you call previous board, okay. So that you can see, for example, if current is passing through a point, okay, then in the circuit only, okay, for example, something you can take circuit, for example, this is plus minus, so some point you can take on circuit, for example, this point P you take, here bulb is there, okay, so for example, here some bulb is there, and here you have tap key, here you have ammeter, etc., for example. So what I am saying is, you take one point on a conductor, for example, so current through a point in a circuit is said to be 1 ampere, okay. When you will say 1 ampere, if 1 coulomb of charge, means mathematical I am saying Q as 1 coulomb, okay, 1 coulomb of charge flows through that point in 1 second in the material. In the material means that in the conducting wire, okay. So material you can write, or wire you can say like this, conducting material, like that, okay. So is called as this what you call definition for ampere, okay. In that way you can write, okay. See, the students who are watching, if you feel that I am saying a little fast, because it consumes more memory in the phone, or whatever the I am using. And also if I am explaining slowly, the video will become more long and more GB will be used, okay, memory. So that is the reason I am saying a little fast, okay. But students, if you want to understand, pause it, see it and copy that, and then you can go ahead. In that way slowly you can do, okay. But I will be saying a little fast because I want to save the memory, okay. Now see here, now next question: how many electrons constitute 1 coulomb of charge in a circuit? See, how many number of electrons, means I already said you, Q is equal to NE formula, I said this formula actually, okay. You might have not remembered, but actually in the previous thing, minutes of the video I said, okay, Q is equal to NE. So they are asking actually 1 coulomb, means if the total charge is 1 coulomb, how many number of electrons will constitute that? Actually the charge for 1 electron is 1.6 into 10 to the power of minus 19. Of course electron has negative charge, protons will have positive charge, that is all we know. Cations have positive charge and anions have negative charge, this is all you know. Remember, electricity is concerned, in solids the current will pass due to electrons only in electrolytes and solutions the current is due to flow of ions, that you remember, first important thing. So in this chapter generally we are going through the conducting wires which are solids, so current will be due to the flow of electrons, okay, that you remember strictly. You fix in your mind that in solids current is due to the flow of electrons, that's it, okay. Now coming to the next, it means generally for now for your class, okay, see in your 12th class you will have semiconductors there, okay, the current will be due to holes also, okay, that is secondary, but for now you can take like this, okay. Now see here, that is about semiconductors. Now see here, now how many electrons constitute 1 coulomb of charge in a circuit? So given, means total charge you have to take it as 1 coulomb, and we know that charge of 1 electron is 1.6, means it means that this is actually, they give Q value and E value. What is that? Q value and E value they give. They are asking N value. Now if you bring E down, then what will happen? N is equal to Q by E you will get. Now in the place of Q you write 1 coulomb and E you write 1.6 into 10 to the power of minus 10. Why? Because we already know the value. This is actually standard value, like how Planck's constant value or gravity G value, acceleration due to G value, okay, pi value 22/7, like that you will take. Now some constant values you remember, right? Same way this is also, okay, like acceleration due to gravity in the 9th class you took G is equal to 9.8, like that. Okay, in the same way here this is also one constant value you have to remember, E value, okay, though they are not mentioning in the question, right? Sometimes okay, even generally actually in the question also in CBS etc they may give charge of in the brackets they may give charge of 1 electron is, okay, 1 electron is, okay, 1.6 into 10 to the power of minus 19 they may give also, okay, it doesn't matter, okay, but generally constant values we try to remember. Now even if they don't give you, right, I am saying. Now N is equal to Q by E, you memorize this value I am saying, okay. Now N is equal to Q by E, so substitute the values, Q is 1 coulomb and this. Now remember, if you are able to divide 1 by 1.6, actually you will get 0.625 into 10 to the power of 19 coulombs you will get, but what I did, this 1 divided with 1.6, it is a smaller number, this is a bigger number, so you cannot do, I thought. So what I did, I wrote 10 to the power of minus 19 as 10 to the power of 1 and into 10 to the power of 18. Why? Because I want to say that, see, for example, a to the power of m plus n is there, so you can write as m into a to the power of m into a to the power of n. For example, this 19 I can write as 10 to the power of, for example, you can take like this also. What I will do is 10 to the power of 19 you can write like this, 1 plus 18 you can write, for example 1 plus 18. Now 1 plus 18 you can write as this formula 10 to the power of 1, okay, this 1.6 will be like this only, and this, in that way you can write. Now dividing 10 with 1.6 is easy for you, 6.25 into this is all you can do. The reason why I am saying is actually if you get the answer in, if you divide 1 by 1.6 is, you will get answer as 0.625. So 0.625 is not the standard way to write the answers generally. The scientific notation is it should be like this, a dot b into 10 to the power of n, this is the power, and this a should be not 0, not equal to 0. So we, whatever the first number will be there to the left of the decimal, it should be non-zero number, okay. So if you write 0.625 left to the decimal, to the point, left side will be 0. If you write like this 0.625, okay, left side will be non-zero number, this actually this should not be 0, right? So a is not 0 I say, right? So in that way, so that is the reason whenever you write, okay, in the form, okay, a dot b into 10 to the power of n something, so okay, so you are getting 0. So what I did is 10 I divided with 1.6, you won't get a 0.625, you will get 6.25 and thereby 6 is a non-zero number, so in that way it will be useful, okay. Alright, now we will go to the next.